All right, this is day 16. Me coding every single day till I become a SWE. Sweet. And yeah, struggles continue. I did not get too much done today. Today was kind of a busy day for me, to be honest, but I got linked list done, kind of into binary trees, which I've always struggled with, and on the binary tree delete, I got kind of lost. Had to request a solution on this one. Yeah, I don't know. I've been watching some tips on leak code and things, and there's some different opinions. Some people think you should, work on the problem as long as possible. Some people say, look at the solution once you get stuck, no matter how soon it is. That's what Scott Wu, the genius guy at Cognition, says. He says he only waits like 10 minutes before he looks at the solution. I don't know, I feel like sometimes my ego comes into play and I think like, I've done this before, I should be able to figure this out. But I don't end up figuring it out, then I just procrastinate. Go watch like Twitch or something. Or one thing I've been I feel like I've been touch typing more than I've been coding lately, which I think is probably not the right way to go about it. This is only practice for, okay, this is a new day though. Yeah, since I spent 6 hours typing this week. Yeah, okay, sorry for the flashbang, by the way. But yeah, I don't think that's, I don't think you should be spending this much time touch typing. As cool it is, like, should not be my primary goal. Primary goal should be coding. I feel like I need to code more, and a lot of times I get kind of annoyed with myself, and I don't like looking at solutions, but I feel like I need to start looking at them more so that I can code longer and do more. But anyways, what's going to happen in this video is I'm going to rewrite the binary search tree, the delete method, so that I know how it works. I had most of it working, but like there are a couple weird instances. And one of the things I don't like about boot.dive is like when I have an error, I don't know exactly where it is because it's like a virtual environment basically. That's why I was having all these print statements. It's very hard to figure it out. But regardless, I didn't think I really had the entire thing back down my head. So I'm going to delete all this. We're going to rewrite it. It's been like an hour since I finished this, so check if the current node is empty. So we should probably set root to this. If root.val is none, we want to return none. There's an empty tree. If the value to delete is less than current node's value, so yeah, value is less than. Then we just need to return delete with the left node, right? Because we're going down the left side of the tree since the value is less, and the lesser numbers are on the left side. Update the left child's reference. So according to value, and then we need to return root, which is the current node, and basically else if the value is greater than root.val, then basically you do the same thing but just for the right node. Right. else if the value to, or basically at this point we know they should be equal. We found the node to delete. If there's no right child, return to left child. So if root.right is none, I want to return root.left. So if there's no right node, we're just going to return the left node as the new head or new current node. Bypasses current node effectively it. I do the same thing for if root.left is none. Return root.right. There's no left node, we're going to bypass the current node and set it to the rightmost node. Else, let's use an else if here for safety. And else, that means they're both left and right. Okay, this is one of the things I forgot last time. I didn't use the get min. I was trying to rewrite the whole entire thing, which is just ridiculous. Yeah, stuff like that. That maybe it's because I'm tired. I just don't notice it, but that really ticks me off. Find the smallest node in the right subtree, right get underscore min. Okay, we're going to set this equal to successor. And it's returning value, so successor is now I'm going to just call it successor underscore value. Hence we know it's going to send a value back. And then delete succession node from the right subtree. By recursively calling delete and update the right child reference results. Turn the current node. Okay, we need to write on the right dot left. Okay, this is going to go down the left. So it's going to give us the leftmost value, which should be the smallest one. And it's also going to be the successor. Replace the current node's value with the successor's value. Then we need to delete the successor node by recursively calling delete, update the right child. All right, equal to we need to delete it from the right. So say right delete current successor value. Delete that node. Turn the current node. Root. Okay, so it went down the leftmost here, right? I can do this in a different color. We went down the leftmost. Say replace the current node's value with successor. And we delete succession node from the right subtree. Or recursively calling delete. The other than the right child reference results. Slightly confusing. Z has both left and right children. If Y is Z's right child, as shown in D, Y displaces Z, and Y's right child remains unchanged. Because Z is what we want to delete, so we're going to remove Z and make Y be the next one, since Y is going to be greater than right. Y lies within Z's right subtree, but it's not. Z's right child is shown in E. Y first gets replaced by its own right child, which would be X, right? And then it displaces Z's position in the tree. Okay, so X becomes Y, then everything basically moves one step up. Okay, I knew that was going to give me the right solution, but I was studying consistently for 21 days. That's nice. Still slightly confused at how that works. So let's see how they did it. Stuff to love you, stuff to. Oh, what this is. Listen to music that Sylvan Frankly Timothy suggested. It's pretty good. Self.left equals self.left.delete. Yeah, same thing. That makes sense to me. If the value is less, then we're going to go to the left side to find it, obviously, because it's probably in the left subtree. Just keep recursively calling until we find it. And once we find it, if it's equal, if there are two subtrees, well, I actually didn't use a function made. Well, I'm in that larger node dot left, and go down the left subtree. They find the smallest value. Oh, they actually find the smallest, largest value on its right side and set the current thing's value to that, because it's going to be the top of the tree. And then recursively call again and delete that value from the list, which basically they just moved it from. They just moved it from here up to the top. Okay, vaguely makes sense. Vaguely makes sense. Isn't it like a DSA visualizer or something? No, that's not it. Damn, why are these people on light mode, bro? So annoying. Bro, oh yeah. think this is it. Why can't I see anything? What? Do I have to insert everything? That's kind of annoying, actually. I guess I could just keep inserting. Oh, 0. Wait. That's 12. Oh, damn it. Making one the delete one. Damn it, why don't they have like an already set up tree? Let's look at these people. So it's like the classic. I don't know why they make you insert values manually. It'd make it so much easier if you just could. I don't know how this is over there. What? How does this even work? This is garbage. Give me some tutorial. I really don't care, guys. What? Okay, so we're to move something like 50. Okay, so that one had no children. So about 6. 6 has 2 children. So it was unlinked and 7 was set to 4. Huh. Yeah, I don't know. I might have to watch a video on this, or a couple videos. Whatever's going on here is not clicking with me. Okay, yeah, that's the end of this video. If you guys have any advice for me, let me know. We'll see you guys in the next one.